So why don't you just give the question at the top a read through, and then we can get started.
All right, sounds good. Array of integers, target. Okay. All right, so it looks like I'm going to be given an array of integers and then a target, and I'll have to return the indices of two numbers that add to the target. So my first thought is that I could do this with an n squared time. So if I were to do a nested loop kind of situation, I could iterate through and find two numbers that add to the target. But I also could do it probably with a constant time if I use a hash map. So
Okay.
yeah, I think
Why don't you start off with just doing the maybe put a note down, and then why don't we start with that first solution you said, just so we get something down, the sort of the brute force approach, and then we can try to expand on it and see if we can get the other one.
Okay, yeah, sounds good. All right, so we're going to have not a comment. So int, well, a for loop. Int I equals 0, I is less than the length of the vector you're using, so nums.
Oh, sorry, do you want to use Python or do you want to do C++?
Oh, I'm more comfortable with C++, if we could do that.
Okay, yeah, that's fine.
Okay.
I'll change this while you.
All right, and then add plus. And then I'm going to have a nested loop in here. Oops, that's not correct. J is less than the, we want J to start at the next number. So we're going to subtract 1 and then increment it, initialize it at 1. And from there, we're going to iterate through. So now we're just going to do our test. Well, let me move this down. So this is our test. So if nums, or I should mention that I'm using nums as our array here.
Yeah, that can be the input. That's fine.
Okay, so if nums at I plus nums at j is equal to the target, then we want to return both of those numbers the indices I and j. So we will return I. All right, so yeah, that would be my brute force approach. Looking at this, because of this j situation here, this would give us that concept of the n square time.
Yeah.
Yeah. So yeah, that's what I would say is the brute force approach for this one.
Okay.
And
then why don't you just that's fine. Yeah, we'll do the hash map one down here. That's fine. Okay. Yeah, that makes sense. I think there's a little bug, and I think the return type might be a little weird with returning two things, but other than that, I think that looks good. Makes sense. N squared time, like you said.
Okay, and then so I'll just walk you through my idea for this hash function concept. So this is going to be my hash thing. So with the hash, the advantage in my mind is that there's a constant time lookup, and the only catch is that we have to add a little bit of space. But if you weigh your pros and cons, yeah. So we'll have a map, a hash map. And we are going to have that store. Well, when we're looking for something that adds up to the complements, looking for something that adds up to the targets, we're going to be looking at a number, and then we'll want the complement of that number that adds to the target.
Yeah, that makes sense.
Yeah, so then we'll have our list of nums be like whatever it is, 1, 2, 3, 4. So that's our array. And then our map is going to hold the complements of those numbers. So for instance, the complement, if our target is, say, 10. So if our target is 10, then the complement of 1 would be 9. And the complement of 2 would be 8, 7, and 6. I'm going to just illustrate this a little bit easier here. Yeah, so the 9 is going to be our index of that map, and then it's going to hold the index to refer you back to this array here. So then this would hold the 1, and that would hold the index, or no, the index. So 0 to refer you to the 1, 8 would hold the 1 to refer you to the 2, and etc. like so. All right, so that's the concept there. So then the benefit here with this constant time lookup is that we're going to fill this map with the complement if it doesn't exist yet in there. And then if it does exist, then we're going to return the index here that'll give you the complement of the number here. So for instance, if we're looking at index, this would be index 3, the number is 4. So the complement of 4 is 6. 6 is here, and then it will take you back to the array.
Are these, do you mean to, are these indexes right here? I think that might be.
Oh, my bad. Yep. That
okay.
Yeah.
And then let's assume that, excuse me, let's assume that there is a solution here, because there wouldn't be one for this here, because the target's 10 and no numbers add up to that. So let's just add 6 in here just to make it so that this actually can add up.
Right. Okay, that makes sense. Yeah. So then, let's see. Complement of 6, just to add to my illustration, would be 4. And this is unordered, so I think it's all right if I just add it here.
Yeah, that's fine. Yep.
And that will return you back to index 4 of your number. Okay. Yeah. So yeah, that's my approach when it comes to the map concept. Basically, it's really just you're creating this temporary map. It's holding the indexes of the complements of whatever number here that you're looking at. So It's probably guaranteed to be different than the index of the number that you're looking at in your numbers array. So this way we'll have constant lookup and with the catch of having temporary storage.
Okay. Yeah, why don't you just write it up?
All right, so if we're going to go ahead and implement that, we have numbers on our target. So we're going to do a for loop here. So for int I, and we're going to loop through the entire number array. So for int I equals 0, I is less than nums length I plus plus. All right, so now we're going to have our if test, and we're going to have 2 statements. We're going to have an if and an else. So the first if is going to tell you if the number at I, so the number you're looking at in your array, if that is in the map, then you will return, not return, you will add it to the map. So you're going to determine if you need to add it to the map or if you don't. So so for this, so we're going to say determine if we need to add to the map. So if nums at I, so if it is not in my map. So let's see.
Yeah, so in, I know what you're going for. It might just be a syntax thing, but for the, I could be wrong. It's been a little bit since I've done the C++ stuff, but I think you have to use the built-in find if you're using STL. So what would you call your map here?
My map, I'll probably just call it map as a name. So
okay, so the syntax for that, it just because it's just a little syntax thing, but it looks like this. Oops, unordered. And then you would call it like my map or something.
Okay. Oh, and I also forgot to initialize that here.
Yep. I figured it was a syntax thing, so that's fine. I mean, you explained it, the way you explained it here, I know what you're going for, so it's just a little syntax thing. So this will basically declare your map for you above your loop here.
Okay, perfect. Alrighty. So let's keep going with this map concept. So all right, so if
yeah, and then this is where it, like in the Python syntax is like not in, but I believe you can do I think it's like find. I think you do like my map dot.
Oh, find as a function. Okay.
Yeah, it's been a little while since I've done this, but you might want to look for, you know, I or whatever you're looking for, and then you would say like it does not equal. I think it's like my map dot end or something like that. That's how you would do it. Again, it's been. I know what you're going for, so if you can just, even if you write it the Python way, that's fine.
Okay. Okay. So if num. Yeah, I might just write it the Python way at first and then come back to it just so I don't waste time.
That's fine. Yeah, don't worry about the syntax. It's fine.
Okay, great. If it's not in my map, then we want to add it to the map. So add to map if not existing. All right, so then we're going to add to the map. We're going to say map, and we're going to take the complement of this because we're making a map of complements. So nums I. Nope, that is incorrect spelling. Is going to take I, the index you're at. So we're going to end that if statement. And then otherwise, if it is in the map, then we want to return we want to direct you to the map's value, which will take you then back to the array, which has the number you need. So we're going to return maps at nums I, which is the number we're working with. Since it exists, it's going to give you a value. And then we're also going to return I, the index we are at in the original array. So the whole idea here is that we're using the map to direct you to the correct complements index in the original array. So yeah, That's what we're working with. Return maps. This is correct syntax. And yeah, so this will execute until you have something to return. And otherwise, if you have nothing to return, because it's, you know, there's
let's assume that there's a solution, so this would be good, yeah.
Okay.
Otherwise, you could return like -1, but this is good, yeah.
Okay.
All right. So yeah, I think there are a couple little syntax things that we can go over if you want.
Okay.
So if I remember what you're trying to do here, the way you do it with like the standard library, I think it's map.find and then what you're trying to find, which in this case would be, I deleted what you had. So numi. So you would say if not find, and then this. And then you would say if it's not found until the end, I believe, something like this, if I remember correctly. And then, so this is what this is just translated over to C++. It could be wrong again, but I believe this is correct. And then this is good. And the only thing here, because in C++ we can't have multiple returns like that, we can just have a result here, and then we can just say, basically, here you would push back these two here. This. So I think that's the C++ syntax there for you. But again, I would give you credit because this is a little syntax thing. It's kind of, once the logic was done for this here, and you explain the runtime, the space complexity, everything. So yeah, it just became basically a standard library test at this point, which really isn't a big deal because that's a quick Google search, right? So, but yeah, well, good job with this one.
All right, great, thank you.